Welcome students to the physics class. Today we are going to start the second chapter of your syllabus, and that is kinematics. Now kinematics is further divided into 4 subunits, and the first subunit is motion in a straight line. So in this subunit we are going to deal with straight line motion. Learning objectives of the topic are: after the completion of the topic, you will be able to define distance and displacement. You will be able to differentiate between speed and velocity, and you will be able to solve the numericals based on daily life experiences. Now first of all, what do you mean by kinematics? Kinematics is derived from two words. It is a combination of two words, that is kinematics. Matics means maths and kine means motion. So simply it means that we are going to do mathematics of motion. That is the terms related to motion, that is distance, displacement, speed, velocity, acceleration. We are going to deal it mathematically. These terms you have already studied in your 9th standard, but here we are going to deal it in the extended form. Now let us start with the topic motion in straight line. We will start with some of the important terms. The very first term is mechanics. Mechanics is that branch of physics which deals with study of motion of material bodies. Mechanics is further divided into 3 categories. The first is statics. Statics is that branch of mechanics which deals with study of material bodies at rest. The second is kinematics. It is that branch of mechanics which deals with motion of material bodies without considering the factors responsible for its motion. For example, force is not considered in kinematics. The third category is dynamics. It is that branch of mechanics which deals with study of motion of material bodies while considering the factors which are responsible for the motion. That is, force is considered here. Now let us look at the next topic, that is rest and motion are relative. Now before coming to this topic, let's recapitulate the terms rest and motion that you have previously studied in your 9th standard. Now what is rest? Rest means when the object is not changing its position with respect to the surroundings. And motion means when the object is changing its position with respect to the surroundings. Now, rest and motion are related to each other. Now, for example, consider a moving car. The driver of a moving car is in motion with respect to the observer standing on the ground, but the same driver is at rest with respect to the man in the passenger seat. So simply rest and motion, they are related to each other and they depend upon the observer. So the object in one situation may be at rest, whereas the same object in the same situation may be in motion. Now the next topic is point mass. This is very important term, point mass. Now an object is said to be a point mass if it covers a very large distance in comparison to its own size. Now for example, Earth is also considered as a point mass because it covers a large distance around the Sun as comparison to its size. Now, further, motion is of 3 types, that is rectilinear motion, circular motion, and the third is vibratory motion. But in this chapter, we will be confined only to rectilinear motion, that is the motion along a straight line. Now, the next topic is position, distance and displacement. These terms, you are also familiar with these terms. The very first is position. Now, position of an object is always defined with respect to some reference point. That is, Whenever we are going to discuss about position for an object, we have to consider origin over there from where the motion will be started. And the two terms related to this are distance and displacement. Distance is the total path covered by the body, and displacement is the shortest path covered by the body. Now, let's differentiate between distance and displacement, which you have already studied in your 9th standard, and let's recapitulate it. Distance. It is the actual path covered by the object during the motion. Displacement is the shortest path, that is the difference between the initial and the final positions. Second, distance is a scalar quantity and displacement is a vector quantity. Third, distance traveled by an object during the motion can never be negative or zero. It is always positive. Whereas the displacement of an object may be positive or negative or zero during the motion. Next point, the distance traveled is either equal to or greater than displacement, and displacement is less than or equal to the distance traveled. This I will discuss at the last with the numerical. Next point is the distance depends upon the path traveled and displacement is independent of path taken by the object. Now let's differentiate between speed and velocity. You are already familiar with the terms speed and velocity. Now speed is defined as the total path length traveled divided by the total time taken during the body during its motion. And velocity is defined as the change in displacement divided by the time in which displacement occurs. Speed is a scalar quantity, velocity is a vector quantity. Speed is always positive during the motion and velocity may be positive, negative or zero during motion. Speed is greater than or equal to magnitude of velocity and velocity is always less than or equal to speed. Now, the next topic is scalar and vector quantities. This again you have already studied in your 9th standard. Scalar quantities are those which have only magnitude but no direction. Now, for example, distance, speed, work, these have only magnitude, that is, they have only size, but no direction is indicated. On the other hand, vector quantities are those which have magnitude as well as direction. For example, displacement, velocity, acceleration, force, etc. Now, let's discuss average velocity and average speed. Average velocity is defined as change in position or displacement divided by the total time during that course of time. Now, SI unit is for speed or velocity is meter per second and the bigger unit is kilometer per hour, and the dimensional formula that you have already studied in the first chapter of +1, that will be m0 L1 t minus 1. Now, average speed is defined as the total path length traveled divided by the total time taken during the course of motion, and its SI unit is meter per second and the dimensional formula is m0 L1 t minus 1. Now, instantaneous velocity and instantaneous speed. Now, instantaneous velocity or speed from the word itself indicates that the velocity or speed at a particular instant of time. Now, for example, the speedometer of a vehicle gives us instantaneous speed, that is, it indicates the speed at every interval of time. Now, instantaneous speed is given as delta x upon delta t limit t tending to 0, that is for a very short interval of time, and it can be written as dx upon dt, that is for very small time dt, the displacement will be dx. The SI unit is again meter per second and dimensional formula is m0 L1 t minus 1. Similarly, instantaneous speed is the magnitude of velocity as given by in the previous case. SI unit is meter per second. Now, acceleration. Acceleration is defined as the change of velocity divided by the time interval, that is A is equal to V2 minus V1 upon T2 minus T1. On this side, on the other side, you can see four relations are given, and these four relations are equation of motion that we will derive in the next lecture. Now let's solve some numericals related to the topic that we have just done.